Okay, we got a video of the external from 2023, Specialist Math, Paper 1, Tech Free. And we're going to do the last question, question 19. There's a lot going on in this question and a lot happening. So let's start. We've got object A is released from the origin with a constant velocity, VA, such that its position after t seconds is given by that formula. At a later time, object B is released from point P and travels towards point Q with a constant velocity, such that VB equals root 2 VA. Given that object A and B collide, determine the time between the releases of the two objects. So not what time they're released, the time difference between. Assume all positions are meters, velocities are meters per second. Okay, so let's talk object A. So RA equals 2 root 3 ti plus 3tj plus 2tk. So the velocity is going to be 2 root 3I plus 3j plus 2k. So the magnitude of that, or the speed, 2 root 3 squared plus 3 squared plus 2 squared, square root of 25, 5 meters per second. And we know that it starts at the origin. Okay, just keeping track of all my bits of information because what may become handy to use later. Now, object B. We know that the speed of object B is root 2, the speed of object A. So that'll be 5 root 2 meters per second is the speed of B. Okay, so we're progressing through. Object B travels from P to Q. So we're going to look for the vector equation of the line PQ. So the direction from P to Q will be, now Q is 5 root 3, 8, 4. P is 3 root 3, 6, 0, giving me 2 root 3, 2, 4. So RB, from my rule for vector equation of a line, is going to be a point on the line. I'm going to go with point P because point P is where did it start? 3 root 3, 6, 0, plus, I'm going to go a different value. I'll go big T. The direction, 2 root 3, 2, 4. So then we're going to go with, if I write that out in component, in ij's and k's, that's 3 root 3 plus 2 root 3 ti plus 6 plus 2 big T j plus 0 plus 4 big T k. So that's where it's traveling. Now, normally you'd go, okay, well, what's VB? Would be 2 root 3I plus 2j plus 4k. So the absolute value of that, 2 root 3 squared, 2 squared, 4 squared, equals the square root of 32, because that's 12, or sorry, that's 12, that's 4, that's 16, which would be 4 root 2. This is where I have an interesting time with this question. from what we're given, it's travelling at 4 root 2, but we're told it's travelling at 5 root 2, so it's actually travelling faster. Now, going across, it's a collision. So RA equals RB. That's how we're going to put it. So we're going to equate RA and RB. Now, if I equate the i's, I get 2 root 3t equals 3 root 3 plus 2 root 3 big T. If I equate the j's, I get 3t equaling 6 plus 2t. And if I equate the k's, I get 2t equals 4t. So equating them out. Now, if we're going to equate them out, we're going to probably, let's go simplest way to go. If I change this one around, that t would equal 2t on 4 or t on 2. Now, if I call these equations 1, 2, 3, I'm going to sub into 1. So I've got 2 root 3 t equals 3 root 3 plus 2 root 3. Instead of a big T, I'm going to go t on 2. 2 root 3t equals 3 root 3 plus root 3t. Subtracted over, I'll get root 3t equals 3 root 3. Divided over, I get 3. Oops, apologies for that. So I get 3. So object A is 3 seconds to collision. That's object A, 3 seconds to collision. Okay, it's released 3 seconds. Now, so where this question's a little interesting, we would be inclined to put 3 back up here and go, well, big T is going to be 3 on 2, 1.5 seconds. So you'd be inclined to go sub into 3 and you get T equals 3 on 2 or 1.5 seconds. And you'd say, okay, difference between release times is 1.5 seconds. The issue is they've actually stated that the B object is actually traveling faster. It's actually traveling 5 on 2 fast, like 5 root 2 meters per second instead of 4.2 meters per second we worked out. Now, I'm going to show you a few different ways, like how I work and how the QCAA did theirs. So I'd go, well, if I did, it's really traveling at 5 root 2 instead of 4 root 2, and my speed is 1.5, what's going to be on top there? Does that make sense? Oh, hopefully that makes sense to you. Is that going to be the right way around? We've got that portion's right. So we're going, once I flip it, and if I made it 4 root 2 on 5 root 2 equals 1.5 over what? And so cross multiplying, the root 2's disappear. Either way, doesn't it? That's actually not going to work. Sorry. That's not working. And this is where puzzling this out is interesting. Now, let's go the QCAA way. I'm going to go for a bit of paper. Now, if object A collides when t equals 3, that means RA3 is 2 root 3 times 3i plus 3 times 3j plus 2 times 3k, which is 6 root 3i, 9j, 6k. Now, in terms of, so that's also going to be this point, 6 root 3, 9, 6 is the collision point of A and B. So point B, or object B, starts at P. Now P we know is 3 root 3, 6, 0. So distance B travelled. Now distance B travelled from 3 root 3, 6, 0 to 6 root 3, 9, 0, negative 3 root 3, negative 3, 0. Oh, sorry, that's a 6. Apologies. So that distance, oops, we need the square root of that, don't we? So that is negative 3 root 3 squared plus negative 3 squared plus negative 6 squared. 9 times 3 plus 9 plus 36. 72, which is 6 root 2 meters. So object B has travelled, this is its distance. So we know speed, distance over time. So time is distance over speed. So it's travelled to 6 root 2 at a speed of 5 root 2, which gives us 1.2 seconds, is how long it took to travel, is its travel time. Now remember, the question here was the time between releases. So that's 3 take 1.2, which equals 1.8 seconds. And that's the answer we're after. I know there'll be some people, because it made my brain hurt a little, is that because it was traveling at 5 root 2 instead of 4 root 2, you could have reasoned that instead of it taking 1.5 seconds, it's really taking 1.2 seconds because it's traveling faster. This is what I was trying to do here, but my brain hurt. Because it's traveling faster than it really is, isn't it? So that's why that would also come down to 1.2, because it's traveling that bit faster proportionally. Anyway, the answer's 1.8. Bit of a crazy question, that one. Bye.